Hi everybody and welcome. Today we're going to be changing up the format just a little bit. Reason being, big vocab day, not a lot of calculation. So I know that the last few videos we've done has kind of been, separated into small chunks where it's like, all right, here's one calculation, here's some example problems, here's one calculation, here's some example problems. Well, in this case, we honestly just have a whole lot of vocab words to take care of today. So take careful notes as I'm going through here. Pause the video, write down these definitions. Make sure you do have these in your notes, whether you're typing and taking electronic notes or whether you're taking notes by hand in your notebook there. But again, all of these things are things we're going to need to know. So if at any point you're not sure about something, flag it, take a note, ask that question in class, and we'll make sure we go through. But again, today, to be totally honest, zero calculations really, just looking at understanding some vocab definitions. So first things first, we are going to be talking about circles. So a circle is the set of all points in a plane that are equidistant. That just means the same amount of distance away or an equal length away from a given point called the center of a circle. So think about this logically. You have the middle of a circle. This point is just as far away as this point, and then if you keep making these points that are all exactly the same distance away, you're going to be making a circle. Now that's a terrible circle because I'm terrible at making drawings, which is why I became a math teacher. But again, kind of get the idea here is that if you make a bunch of points that are exactly the same distance away, it makes a circle. All right, so how we name circles, if the center of a circle is point C, then the circle is just named circle C. So the symbol for a circle is not an O, it's an O with a dot in the middle. That's how we can differentiate them. So that's the symbol for that means circle. And then you just name it the point that is in the center. So you have interior points. That's anything that's inside of the circle. And then exterior points are anything that is on the outside of the circle. So for example here, that's inside of our circle. So we would say A is on the inside, but something that's on the outside would maybe be G. So if you're answering a question like this, obviously list everything that's on the inside and everything that's on the outside. So we'd have A, B, C, and D are on the inside, and then we have G, we have F, and we have E that are on the outside. And again, just seeing quite literally, are they inside or are they outside? Next, chord, that's a line segment. So not a line, but a segment because it stops, because its endpoints are on the circle. So it has 1 point and 1 point here, and both of those are, again, on the circle. That's the only rule for a chord. It can be any combination of things as long as both of its endpoints are on the same circle. All right, keep moving on to diameter now. So a diameter is a chord that passes through the center of a circle. So for example, if we started here and here for endpoints and we want to cross, that is a diameter, and by definition, it is also a chord. Diameters are special again because they go through the center of the circle. All right, moving on to our next set of notes here. Going to be looking at the radius of a circle. So the radius, this is a segment that has the center of the circle as one of its endpoints, and a point on the circle as the other endpoint. So to be clear, it starts in the middle and it ends on the edge. So it's basically like half of a diameter, half the length of a diameter, because it doesn't fully go from one side of the circle to the other. It starts in the middle and then it goes from its way out. So we see here CA or AC, you can name them either way, is a radius of circle C. All right, so again, you can draw a bunch of these. There are infinitely many radii of a circle. You could say that like CB is a radius of circle C as well. All right, next up, continuing with our notes here. By definition, all radii of a circle are congruent. That just means that they're the same length. They all start at the center and they all go to the edge. Again, those points on the edge of the circle, by the definition of a circle, they're all the same distance away from the center. So again, in this case, we're going to see that they are congruent. They have the same length. So it does not matter which radius or where you take the radius, it will be the same length. Second thing, like we mentioned before, diameter is exactly twice the radius. So put two radii together and you get one full diameter. Other things, tangent, so this is different from the trig function that we were talking about before. Tangent, this is a line in the plane of a circle that intersects at only one point. And that's actually really hard to do, to draw a line that intersects only at one point, because usually with, error of hand, you'll intersect at like 2 points. But point of tangency, this is where the tangent intersects the circle. And again, it's perfectly drawn. Can't emphasize enough how hard it is to do this. You're drawing, just barely touches once and then keeps going. If you did it any other way, you'd be crossing through the circle multiple times. Another thing here, a common tangent, is if you have a line, so tangent line, that continues, and then we are saying that it intersects more than one circle at exactly one point. So intersects here at exactly one point, so a common tangent. Again, intersects two different circles, but it intersects each of them only once. All right. So a common external tangent, this is a common tangent that does not intersect the segment that joins the centers of circles. A common internal tangent, this is a common tangent that does intersect the segment that joins the centers. So basically what you would be doing here is drawing an imaginary line from the middle of the circle to the other middle of the circle. And the tangent is external. Basically, if it stays outside of that, it stays away from it. And then this internal tangent idea is the same idea. It's still a line that intersects two circles, but we have a little bit of crossover here. So if it basically is on top of one circle and on the bottom of the other circle, then it is an internal tangent because it goes in between. So you can think of it that way. Common internal tangent goes in between the circles. External tangent stays basically above or below these circles here. All right, next, secant. This is a line that intersects a circle at 2 points. It's pretty similar to a chord, but the difference with secant is that it keeps going. So it doesn't just stop. It does not have endpoints on the circle. It keeps going. And then concentric. These are multiple circles that have exactly the same center. So you can think about, like, here is one circle in blue, and then maybe we have a circle in green. Again, they're all the same, different sizes, but they have the same middle point. So again, that is concentric. Multiple circles basically overlapped on top of each other. All right, and our last set here, two circles are congruent if they have congruent radii. So we can say this for sure. If the radius measure of one circle is equal to the radius measure of another circle, we can say that overall the circles themselves are congruent. Might see that come up in proofs later. Two circles that have no points of intersection. So there's actually two different examples. This might seem kind of obvious. You're like, all right, Mr. Reardon, like just draw a circle that doesn't intersect another one. Yes, that is true. But another example, it looks kind of weird, because you can kind of have that bullseye idea going on. A circle inside of a circle. Again, they do not cross. The edges, the lines of the circle itself is not actually crossing, the edge of the other circle. So both of these are example of circles that do not intersect at any point. All right, we're going to keep going here. So circles that are internally tangent, they intersect at exactly 1 point, and they do so on the inside. So again, intersects at exactly 1 point here, and it does so inside of the circle. Externally tangent circles, similar idea. They intersect at exactly 1 point, except in this case, we're going to see that they do so on the exterior of the circle. So that's the difference. Again, they both intersect at 1 point. That part is the same. The part that's different is where they are doing it. Next, two circles that have exactly 2 points of intersection. There's only one way to do this one. You just draw it, and then the other one kind of goes through it a little bit. Kind of looks like a Venn diagram. And again, they cross at exactly 2 points. And our final example today, our final piece of notes here, is two circles that have an infinite number of points of intersection. So here's one circle. Like, how do you do that? Well, actually, you first need to get kicked out of your notes. But after that, you draw a random line. Sorry, back to focus. So two circles that intersect an infinite number of times. They're actually the same circle. So again, it's basically just transcribed over itself. So you're basically drawing the same circle twice, except, the second time through, you're drawing it on top of the second circle. So that is the way that we have an infinite number of points of intersection. All right, so a lot of vocab today. Maybe watch this video twice, make sure all the things we have written down here you also have written down as well. And I'll post a copy of the template of the notes that I took here. That way, if you want to print it out and write on that as well, it might save you a little bit of time. But either way, all these vocab words, these are important to have, so make sure you got them all written down. And if you do that, you will be in good shape to start off our unit on circles. Thanks so much for watching.